Good morning, students. In continuation of our syllabus regarding the Laplace transformation, let me take some properties in the Laplace transformation. The Laplace transform of elementary functions, where a is a constant. The first term is taken as a is a constant. Then L of a is equal to integration between 0 to infinity e to the power minus st into a. F of t is equal to a. That's all. There is no other thing. What is the nature of a? A is a constant. Therefore, integration between 0 to infinity e to the power minus st into a dt. Take the integration keeping a outside. Integration of e to the power minus st with respect to t is what? E to the power minus st divided by minus s, and the limits are between 0 to infinity. Therefore, keeping minus a upon s outside, e to the power minus infinity is what? Put t equal to infinity. What happens here? E to the power minus infinity. And e to the power infinity minus infinity is always 0. Minus e to the power 0, because t is equal to 0, the lower limit. Therefore, e to the power 0 is 1. Therefore, after simplification, it will be a upon s. Therefore, L of any constant is equal to constant divided by s. You are getting my point? If a is equal to k, what is L of k? K is equal to a upon s. Then come to the second term, exponential function. L of at is equal to integration between 0 to infinity e to the power minus st into e to the power at. Here f of t is equal to e to the power at with respect to t. Making some arrangement in the power, because the power is same, e to the power minus of s minus a into t dt between 0 to infinity. Therefore, putting t is equal to 0 and infinity, again e to the power minus infinity is 0, putting t is equal to 0, that is 1, and minus 1 upon s minus a, minus 1 upon s minus a is the constant. Therefore, after simplification, it will be 1 upon s minus a. Therefore, L of e to the power at is equal to 1 upon s minus a. Okay, can I put one condition here? What is L of e to the power minus at? It will be 1 upon s plus a. Keep in your mind, if a is there, it will be minus a. If minus a is there, it will be plus a. Then L of cos hyperbolic at, I mean the hyperbolic function. L of what is cos hyperbolic at? E to the power at plus e to the power minus at divided by 2 under the Laplace transformation. Therefore, taking L inside, therefore L of e to the power at, just we have concluded the example, it is 1 upon s minus a plus, as I already told, if there is minus sign, this term will become plus. Just observe here. That's why I taken this example. Taking the LCM, 1 upon 2 into taking the LCM, it will be 2s upon s square minus a square in the denominator. And therefore, after simplification, it is s upon s square minus a square, where a is always, s is always greater than a. Similarly, sine hyperbolic at. What is the definition of sine hyperbolic at? There is a minus sign, that's all. If it is cos hyperbolic, it is plus, and if it is a sine hyperbolic, it is minus. Again, the procedure is same. Just for convenience, I have taken this example. Refer the difference between cos hyperbolic and sine hyperbolic, that's all. If there is a cos hyperbolic, this is plus, and for sine hyperbolic, this is minus. Next, come to t to the power n, some arbitrary, some algebraic term, like t square, t cube, t to the power 4, like this. Therefore, L of t to the power n equal to, not t, L of t to the power n equal to L of comma of n plus 1 divided by s raised to n plus 1, where n is a constant for any constant. If n is a positive integer, it is n factorial divided by s raised to n plus 1. To get the summary of the terms, I have taken the example in this manner. Okay, these results are as like as the results what you have seen in the calculus. Nothing to worry about the substitution and simplification and the derivation also, but this table you need to write for 10 times for the practice purpose. All the 8 results to be keep in your mind, okay, while doing the examples. Otherwise, you cannot do anything about the Laplace transformation. Therefore, find the Laplace transform of cos hyperbolic square 3t. Just for using the table, this table I am observing, applying the same results on some of the example. Cos hyperbolic square 3t. What is cos hyperbolic 3t? e to the power 3t plus e to the power minus tt divided by 2. Since there is a square, there is a square here. Okay, go for expansion using a plus b bracket square. Therefore, applying Laplace on each term separately, observe here, each term separately, and using the table, use this table, e to the power at, e to the power minus at, and constant. You are getting my point? E to the power at, e to the power minus at, and constant term. Therefore, after it will be, need not go for any simplification, keep it as it is. Based on same fact, here just observe e to the power minus 2t into sine hyperbolic 4t. Just observe here. Here there is no such a difference between e to the power minus 2t and sine hyperbolic 4t. Why? Because we need to consider sine hyperbolic in terms of exponential. Sine hyperbolic in terms of exponential. Therefore, e to the power minus 2t into e to the power 4t minus e to the power minus 4t divided by 2. This is the definition of sine hyperbolic 4t, keeping in bracket between the bracket, and go for the simplification, keeping 1 by outside. E to the power minus 2t e to the power 4t, it will be e to the power 2t minus e to the power minus 2t e to the power minus 4t, it will be e to the power minus 6t. Applying the Laplace on each term, this will be 4 upon s minus 2 into s plus 6. Similarly, f of t is equal to sine 5t into cos 2t. Here, if you find only either sine 5t or cos 2t, okay, no problem. But there is a product of two terms, sine 5t cos 2t, using transformation formula in a trigonometry, sine a cos b. What is sine a cos b? 1 by 2 into sine of a plus b plus sine of a minus b. Compare this result with our given condition, I mean the given example. What is a? 5t. What is b? 2t. Observe this condition. Therefore, what happens here? 1 upon 2. This 1 upon 2 will come outside. 1 upon 2 into sine 7t plus sine 3t. Therefore, this term is equal to, after simplification, this is s 7 upon s square plus 49 plus 3 upon s square plus 9. If there is a sign, it will be in this manner. And at the end, sine square of 2t plus 1. This is using sine square theta is equal to 1 minus cos 2 theta divided by 2. I am using that condition. Therefore, observe the Laplace on each term separately. Observe the terms carefully. Cos of 2 into 2t plus 1. It will be 4t plus 2. Therefore, using cos of a plus b expansion, what is the condition? Cos a cos b plus sin a sin b. There is a cos 2t here. Make the correction. Here it is cos 2t, cos 2 and plus sin 4t sin 2, using cos of a plus b. Therefore, applying cos 2 becomes constant, keeping as it is. Laplace of cos 4t, what is the term? S upon s square plus 16. L of 1, 1 upon s plus the third term, sin 2, keeping as it is. Laplace of sin 4t, 4 upon s square plus 16. These are some of the examples which are taken from this table. That's why I am suggesting you to, I am advising you to practice this table. You know that what? Differentiation of sin theta is equal to cos theta. In the same way, L of sin at is equal to a upon s square plus a square. L of sin hyperbolic at equal to a upon s square plus a square minus a square. You need to get the result in this manner. Okay? Yes. Thank you.